welcome to class 15 video. We're into a science module now. 105D, matter, density, and relative density. Okay, so I'm going to go over a few points and then we'll do a couple of sample problems and you'll be away with it. So we are introducing another formula triangle, mass, density, and volume. And we know how these work. We're looking for mass, density times volume. If we're looking for density, mass divided by volume. And if we're looking for volume, mass divided by density. So let's just think about this word density and what that means. Density of a substance is the mass per unit of volume. So we've been talking about what water weighs per cubic foot. That's the density of water. Okay? So here's some numbers we're going to need, because when we're putting in density in the formula triangle, these are the numbers we're going to use. So we know that each cubic foot of water weighs 62.4 pounds. We know each cubic meter of water is 1,000 kilograms. Now these air numbers are new, okay? So if you do get these on an apprenticeship exam, you'll be able to look them up or they'll be in a chart somewhere. But these are the two most common ones. So per cubic foot of air, it weighs 0.076 pounds per cubic foot of air, and in metric, 1.29 kilograms per cubic meter. Okay, so these are numbers we've already discussed, and they're in the I need to know these pile. Okay, again, the weight of water is going to come in here to play. We also know that 1 imperial gallon is 10 pounds, and 1 US gallon is 8.33 pounds. Okay, so when we talk about this relative density, so density is what something weighs per cubic foot, per the volume. Relative density is the number of times a substance is heavier or lighter than an equal volume of air or water. So liquids or air that are different than water, we compare them to water. So the relative density of solids and liquids is found by comparing the densities to the density of water. So that means we're going to be comparing them to these right here. Relative density of gases is found by comparing densities to the density of air, which is these numbers right here. So again, the relative density, something that's going to be so many times heavier or so many times lighter than water or air. Here's a key here. Relative densities are the same for either metric or imperial. So what I mean by that, if a liquid is 1.3 times heavier than water, doesn't matter whether we're working in imperial or metric. Okay, we're going to go through a few sample problems here to get you going. Okay, here we go. We're going to go through a few sample problems using the formula triangle and using our density of water and air numbers. The first one, calculate the mass of 5,250 cubic feet of air. So we're looking for mass, so we're looking at our formula triangle. It's density times volume, right? We know that each cubic foot of air weighs 0.076 pounds, so 0.076 times the volume that's given to you right in the question. Just multiply it out, we get 399 pounds, okay? Number two, what is the density of a solid that has a mass of 550 pounds and a volume of 3.5 cubic feet? So we're looking for density, it's mass divided by volume. Now this one here, the two numbers you need are right in the question. All you need to do is put them in the formula. I have complete faith you're capable of this. So we take 550, we divide it by 3.5, and we get that this would weigh 157.14 pounds per cubic foot. Okay, remember the density is in volume, it's per cubic foot or per cubic meter. Number three, what's the volume of a solid that has a mass of 435 pounds and a density of 765 pounds per cubic foot? So we're looking for volume, right? Mass divided by density. And here again, both the numbers you need are right in the question. Go to work, get it done. 435 is the mass, the density is 765. We're looking for the volume, we get 0.57 cubic feet. Okay? Three different ways some of these questions can be thrown at you, right? We're going to use the formula triangle. Sometimes the two numbers you need are right in the formula. Okay? Don't overthink it. Sometimes we will need the density of either water or air. All right? The next two are a little bit more complicated, but I know you can do it. This is where we have to talk a little bit about relative density, and again, relative density, something is so many times heavier or lighter than water or air. So, what would the mass of 10 US gallons of a liquid, we don't know what it is, with a relative density of 1.25. So whatever this liquid is, it's this much heavier than water, okay? So, relative density of a liquid is compared to the weight of water. So, first thing we gotta do, we have to figure out how much 10 US gallons would be if it were water. We know how to do that. 10 times 8.33, we get 83.3 pounds. This other liquid, whatever it is 1.25 times heavier than that. We just multiply that out and we get 104.13 pounds, okay? So what we did there, we figured out if this were water, what it would weigh, and then this other liquid is 1.25 times heavier, so we just multiply it through, okay? This one, what would be the mass of 3.5 cubic meters of a liquid with a relative density of 1.3? So again, whatever this liquid is, it's 1.3 times heavier than water. So the first thing, we know how to figure out what 3.5 cubic meters of water would weigh, right? Because we know each cubic foot of water is 1,000 kilograms. So 3,500 kilograms. I'm sorry, 3.5 times 1,000, took a step. There's our weight in kilograms. If it were water, that's what it would weigh. Whatever this is, it's 1.3 times heavier than the water. We multiply it by 1.3, 4,550 kilograms, okay? So the relative density, we're comparing it either to the weight of water or to the weight of air. In these two examples here, we compared to the weight of water, okay? Now, relative density, just another word for relative density is specific gravity. So again, we have words that are interchangeable in your trade, but relative density and specific gravity mean the same thing. When we're working through this module, they do use both terms, and I didn't want that to confuse you. So everyone have a great day. I know in this class we have a class assignment and a quiz, and we will be highlighting some items in the module, and then you'll be able to finish those up. Thank you.